Hi everyone, we are delving into exponents and simplifying and such, and let's first of all just go review all the properties that you've had in the past. First one, the multiplication property for exponents. A to the power of m times a to the power of n is a to the power of m plus n. We add the exponents. So that would say like x squared times x to the third is x to the fifth. 2 plus 3 is 5. And if you think about that, that's x times x, and this is x times x times x. And what are you looking at? You're looking at x to the fifth power there. And then division, a to the power of m divided by a to the power of n. The bases are the same. The exponents you subtract from the numerator exponent minus the denominator exponent. So that's a to the power of m minus n. And then when you have a negative exponent, you rewrite that as the reciprocal of the positive exponent. So a to the negative nth power is the reciprocal of a to the nth power, which we usually write as 1 over a to the nth power. Zero exponent property. Anything to the power of 0 is 1. A is not 0 in this case, though. Okay, the power of a product. Here's the product, a times b. That's my product. And we're raising that product to a power. Notice the parentheses. And what you do is you take a to the power of m times b to the power of m. You kind of distribute that. And this is why it works. Well, I won't go into that. We'll talk about that more in class. But this is the property there. And then power to a power. A to the power of m, with that raised to the power of n. Here you multiply to get your new power, a to the power of m times n. And then the last one we will deal with, the power of a quotient. A over b to the power of m is a to the power of m over b to the power of m. Okay, let's get into just some simplifying examples. I got these on the next page here. All right, properties of exponents, just some examples. We're going to simplify all these. So, number 1 here, I got negative 3ab to the fourth times 4ab to the negative third. So, if I were to remove parentheses and just times and just rearrange, I'm going to put the coefficients. I got negative 3 times 4. I'm going to keep those together. And then I got times a, and I'm going to group those together when I multiply. I'm just rearranging things. And then times b to the fourth times b to the negative third. I'm just going to do the multiply the coefficients together, multiply the a variables together, and multiply the b variables together. Negative 3 times 4 is negative 12. A times a is a to the second. B to the fourth times b to the negative third. If I add 4 and negative 3, I get 1. And you can write the 1, or you can just leave it as negative 12a squared b. Now my second example here. First thing I'm going to do is distribute this 3 between all the terms here. And that is, I'll put equals here, 2 to the third, x to the third, and y squared to the third. Now 2 to the third power is 8, x to the third power here, y squared to the third power to a power, you multiply those, and that's 8xy to the 6th. Now, number 3. Okay, you could distribute this and everything, but you got something raised to the 0 power. And anything raised to the 0 power is 1. So 3a times 1 is 3a. And that's what I do. Let's just cut right to the chase here. Fourth example. Now it looks like the quotient and the product power properties here. So I'm going to, first of all, just put 5x cubed, raise that to the second, and then raise y to the second. The numerator to the second power, and then I'm going to do a little more to the numerator. I've got 5 to the second power times x cubed to the second power, and that's over y to the second power. 5 to the second power is 25. X cubed to the second power is x to the 6th. Need to multiply, and then I got y squared. Can't simplify that anymore because those are not the same variables. So there's that. Number 5. Now, I want you to notice that the only thing that is to the negative second power is the x, not the 3. Now, I'm going to write 1 over 3, and I'm going to write, okay, I'm changing my mind as I go along here. 1 over 3, I'm going to rewrite the 1 over x, or the x to the negative second is 1 over x squared. Now, I'm going to do something here just to show how it's working, but 1 over x squared, I'm going to multiply by x squared, and I'm going to multiply the top by x squared. I'm not changing anything. I'm multiplying top and bottom by the same number. But when I do that, these are reciprocals, and they'll cancel out, and that gives me x squared over 3. Now, if I'm going through this, a negative exponent, if it's in the denominator, I can move it up to the numerator and make it a positive exponent. So that x to the negative second power, I can move up to here, and that's x to the second power in the numerator. It's x to the negative second power in the denominator. It is just a reciprocal function, negative exponents, but I do end up there. So rather than going through that, you might want to just use that little shortcut there. And the 6th example here, I've got, I'm going to kind of split these up into 3 parts. The coefficients, the a variables, and the b variables. So I've got 12 over 4 times a cubed over a to the negative second power times b to the negative 4th power over b. And the 12 over 4 is equal to 3. And then a to the 3 minus negative 2 is 3 plus 2, which is 5. The power of a is 3 minus negative 2. And then b to the negative 4 minus 1, that's negative 5. And I'm going to take one more step here. I'm going to take 3a to the 5th, and you know how when I had x to the negative second on the bottom, I moved up to x to the second? I'm going to move the b to the negative 5th down to the numerator and make it b to the 5th power, because b to the negative 5th is 1 over b to the 5th. And I'll go with that. And then one more example here. I think the best thing I can do here, you notice how we're talking about the negative exponents are reciprocal functions? Here's what I'm going to do. I'm going to rewrite the reciprocal of 3x squared over y as y over 3x squared and change the negative exponent to a positive exponent. So you do a reciprocal and you do a reciprocal again. That means they're equivalent. And now I'm going to distribute, I got the y squared over the 3x squared, and that's y squared on the top. And then 3 to the second power is 9. X squared to the second power is x to the 4th. And that's my answer for that 7th example. All right, you guys take care.